So I promised you guys in the last video that I'll be solving a more sophisticated problem in arithmetic sequence. Sure. If p times the pth term So if p times the pth term of an arithmetic progression is equal to q times the qth term, prove that p minus qth term is 0. So let's say, so p times the pth term, which we can represent as, so first of all, let's consider that a is the first term of the progression, so a plus, because it's the pth term, n is equal to p, so a plus p minus 1 times, let's consider that the common difference is d. Here we go. Now, same thing with q times first term a plus n equals q minus 1 times d. There we go. So expand this. P a plus pd times p minus 1, which is equal to q a plus qd times q minus 1. Now expand this more, so it'd be like pa plus p squared d minus pd equal to qa plus q squared d minus qd. There we go. Now what I would do is I'd want to take this and this to one side, because remember, prove that p minus q is determined. So if I take this to the other side, we could take a as common, and we'd add p minus q times a, and we'll take this to the other side. So p a minus q a is equals q squared d minus q d. That's the other side. P squared d plus p d. Now I'll basically take a as common, because you've seen it up there. We want the p minus q to come. Don't worry about the a. We'll see what happens. We might cancel with some stuff over there. So yeah. So a minus q is equal to, as you can see, q squared q squared d q d p squared d p d. You can take a d as common, so you have d times q squared minus q minus p squared plus p. D is common, people. Because I don't have enough space, I'll be rubbing off the question also. Rubbing off probably till here. We finished off here. Let's go. 8 times p minus q is equal to d times, and guys, q squared minus p squared. Does that remind you of a squared minus b squared is equal to a minus b, a plus b? Yep. So q squared minus p squared, so it'll be q minus p q plus p. And we've got p minus q. Take a second. Minus q plus p. There we go. Now, come to think about it, how about we take q minus p as common? So, a times. Now, if I wanted a q minus p here so that I could cancel that out, I'd probably want to make this negative so that I have q minus p, basic integers, because like minus a times q would give me minus q, minus a times minus p would give me plus ap. So minus plus, and you land up to the original expression. So this is equal to, take q minus p as common, so d times q minus p times q plus p minus 1. Yes, because that would give you plus p and minus q. So close the brackets. Now you guys can cancel out q minus p and q minus p. So cancel out. Take this to the other side. Divide. Yeah, a is equal to d times q plus p minus 1. Now, what you could do would be oh yeah, I forgot about the minus. Take a to the other side, so 0 is equal to a plus q plus p minus 1 times d is equal to 0. So you see, q plus p could refer to n. From our original to our, you could refer to this as n. Remember the original equation where term n is equal to a plus n minus 1 times z. So This is the n in the equation, and this is the minus 1. And you see we were meant to find the p plus qth term. We were meant to prove that it was equal to 0. Now, we just done it. So what we can figure out is that t, the term p plus qth, is equal to 0. And it's proved. Thank you very much.